Okay, so as a review, we're doing a long division question because that's what we learned last class. X goes into 3x cubed, 3x squared times. We distribute that, and then I draw the line, and I change the signs where I can add now. So I get negative 4x squared, bring it on down. Do it again. X goes into negative 4x squared, negative 4x times. Multiply. Negative 4x squared, and then a negative 4x times a negative 1 is positive 4x. Draw the line, change the signs so I can add. 2x. Bring it on down. X goes into 2x 2 times. Distribute. I get 2x minus 2. Draw the line, change the signs. I get 10. So my quotient, did I make a mistake? Because you know I do.
Oh, I said 2001.
So then from here we add on a fraction of the divisor, 10 over x minus 1 for our remainder. What part, huh? You got 3x squared
minus 4x
plus 10. So you missed something where I'm pointing here. Can you see where I'm pointing, Devin? See where I'm pointing? Did you have a 6x minus 4x in there? No? Okay. So you guys, when I go to quickly look at answers, I can tell if you've done it right, usually by looking at the remainder. Because if you've made a mistake somewhere after like the 3x squared, you'd have the 3x squared right, but then you miss everything else. I know your mistake is somewhere in between these here. So like if you had started out the same way, but then you have stuff different, that's telling you where to look for your mistake. So today we're doing a different method of division, but I have to warn you. First of all, it is easier, but also it doesn't always work. So we have to learn this because this way always works. But if it is a certain case, you can do this other method, which is easier than this. What does that say? What's wrong? What's wrong? Do you need a Band-Aid? Okay, I have a Band-Aid. You don't need to go first. He said no passes. You heard him.
Oh, yeah. Well, if it's an emergency, then.
Yeah, if it's an emergency, that is not an Okay. So today's notes, you can only use certain cases. What I'm about to describe to you is written out really long right here. I'm not going to read word for word. I'm going to show you how to do it. But the one thing I am going to describe is that this is called synthetic division. It can only be used when the divisor, what you're dividing by, the divisor, is in a form of x minus k. So k would be a number. So what I know about what we're dividing by, and this would be one that you could use this for. It is in a form where we have an x. The x is by itself. There's not like 2x. The x has an exponent of 1, so you don't see an exponent. So it's just x by itself. And then with a number. It could be like plus 4. It could be like plus 4. Because minus k would be like minus 4, which would be plus 4. So the biggest thing about it is we have an x with 1 as the coefficient and 1 as the power. So this is linear. If it is in that form, then we can use this synthetic division method. It looks really long. I think this is confusing to read. I think let's just do it. I'll show you how fast it is. Okay? The first thing we're going to do is we're going to find, and they talk about the k value. So this is the first thing we're going to do. Find something called the k value. Okay? To find the k value, I'm going to take the divisor, and I'm going to set it equal to 0, and I'm going to solve for x. Okay, this is how I'm going to find my k value. So in this equation, my k value, or the divisor, is x minus 3. So I'm going to set that equal to 0. I'm going to solve for x, and what does x equal? 3. So what's going to happen is it's always going to be the opposite sign. We've done this stuff before, right? Now what I'm going to do next is only using numbers. It's not going to use x's. So I'm going to set up my k value is going to go in this little box. So my k value is 3. It's like a half box. Okay? So that's k value. And then next is going to be, I'll write it in blue, but I'll actually work the problem in pencil. It's going to be the coefficients. And then I'm trying to think how to word this. Remember how we have to have placeholders for the x's that we're missing? So we have to have zeros as placeholders. So I'm going to say coefficients with 0 as placeholder if we need it. So the coefficients I'm talking about is the dividend, which is what we're dividing into, the part that goes underneath that square root symbol, not square root, division symbol. What is my first coefficient? Coefficient is no x's. So negative what? Negative 1. So that's x cubed. My x squared is what? How many? 4. So I'm just going to write 4. I'm not going to write plus 1. I'm going to write 4. And then my next coefficient would be x. There aren't any, so I'm going to put a 0. And then my constant would be the last one, 9. So you do have to have all the places. Once you start at cubed, it has to be all the places. You do not go higher. You go lower from there. Please. And then from there, I'm going to skip a space because I'm going to be filling stuff in a moment. I'm going to skip a space, and then I'm going to draw this line. So you see I have a space where I can write stuff. So this is how I set it up. Now this is synthetic division. We're going to first always bring down whatever the first number is. Bring it down. Then we multiply that number times 3. So what's negative 1 times 3? Okay. So that's going to go underneath the 4. And then after we do that, add the 4 plus negative 3. What's 4 plus negative 3? Okay. Now I'm going to repeat the process. Not yet. This is a, oh gosh, how do I describe it? It's kind of like a trick that allows you to do this without doing everything. You know, in math, we become efficient, where we know that there's going to be x's and signs and stuff when we're done, but this is just getting the coefficients for our answer. Okay? So these are just numbers for now. So now I'm going to repeat the process, which means take this number, 1, multiply it by 3, just 3, put it under the 0, and add them. So 0 plus 3 is 3. Repeat the process. 3 times 3 is, put it under the 9, add them, 18. Okay? Now what I'm going to do is I'm going to put a box around my last number. And I'm going to put a note there for you. This is the remainder. Okay, that's why I put a box around it, so that helps me remember this is the remainder. Now, I'm about to help you get the final answer, because we're almost done, if you can believe it. Originally, we were in a cubic equation. You know what I'm talking about when I say cubic? To the 3rd power. And we were dividing out 1 power of x. So if I start with a cubic and I divide out 1 power of x, it becomes a quadratic. Right? If I had 3 x's and I divided one of them out, we only have 2 x's. So this here is going to be quadratic. These are the coefficients. This is the remainder. So since I know it's going to be quadratic, I'm going to start with negative, and I don't have to put the 1, x squared, plus, what's my next x exponent going to be? So this is 1x or just x, plus 3 by itself, because we're making our exponents go down 1 power each time, and then plus 18 over our original divisor, x minus 3. Done.
Wait a minute. How did
Oh, we like
this
this.
work every time?
Does it work every time?
Yeah, how do you?
No. Remember the discussion I had before we started?
Wait. I want to know. It won't work every time. Then.
Hold on. It only works when the thing that you're dividing, the divisor, is in the form of having an x in front, not a 2x in front, or having just an x, like x to the first power. It only works when it's in this form. You could not divide by something that was like x squared minus 4. So, or 2x minus 4, yeah. It has to be in that form, but that form happens a lot for what we do in next. So knowing synthetic division is going to save you a lot of time.
When it's got 2 in front of it or anything.
Then you can use it. Okay, I am going to do more than one example.
So like you take a long problem
Mhm.
and you just write down the numbers
Mhm.
that's associated with them.
Mhm.
And then you take the second problem, take the regular number, and then see this is this.
Let's do it again so that you get it. What happened? What we're dividing by, the outside one, the one that would be out here. Oh, I'm sorry. The one that would be right here. Yeah, this is the divisor. This is the dividend. And this is the quotient. Okay? All right, so let's try the next one. We're going to start by finding our k value. So we do x plus 1 equals 0. So what is our k value? Okay. So I'm going to put that in the box, negative 1.
Value
Why don't we just use K as the variable?
we don't need any more letters, okay?
I don't know what you mean by use that as the variable.
Like, I know you can't replace it, but like, if I wrote K equals -1,
Oh, you mean over here?
yeah.
Oh, I don't care. Yeah, that's fine. Here, k equals negative 1. There you go. Okay. Just put whatever number it is, put it right here. Some people don't even need to write this out, like, oh, it's going to be negative 1. Right? All right, so now we're going to put our coefficients, and we have to make sure that if there's any placeholders that we need to put a 0 in. So I've got 3x cubed, got negative 2x squared, I've got 2x, and then I've got my constant 5. So I didn't need any placeholders. I skip a line, and I'm going to make this kind of addition line thing. We always start by bringing the first one down. So you have to bring it down to start. And we do multiplication, 3 times negative 1. We put it under negative 2, negative 3, and we add them. Negative 5.
So you bring down the first one,
Always bring down the first one.
and then you take the first one times it by negative
Wait, so when you use the coefficient, you have to also use the sign. Make it like a negative.
Yes.
Okay.
-5. And then
So we are multiplying, putting it in there, adding the column. Multiply, put it in there, add the column. The last one gets a box. 'Cause the remainder.
on the second line,
Yeah.
for the third number,
The negative
number
sign.
5, you left the 5. Like, how did you get it? Like,
I did -5 times -1, which is positive 5.
So when you get that after you plus it,
Okay, so this was cubic, this was cubic, this was cubic, and we divided out x to the first. What's our answer going to be in the form of? Quadratic. So we'll have 3x squared. We put the signs back in, minus 5x plus 7. Now here's one thing that I don't know if Big Ideas cares about, but usually if it's a negative remainder, they will write minus, and then they'll put 12 over x plus 1 instead of plus -12. They'll combine the plus -12 and just make it a minus sign. I don't know if Big Ideas will mark it wrong if you put plus negative. I don't know. You'll have to try that today and see.
Wait, why is like at the beginning of the answer when it's like 3x squared?
Yeah.
Wouldn't it be like 3x? Yeah, because we bring.
It was 3x cubed. But remember when we were doing long division?
I'm saying. Oh.
When we were doing long division, remember the first thing I said was take 3x cubed and divide it by x. Remember? That was the first thing we had to do. And what do you get? We get 3x squared. See how those numbers are exactly the same? So this will always go down a power from the original because we're dividing out in x from all of those. Let's do another one. Number 3. What would be my k value? Positive 2. And then we put 1, -3, -7, 6. Let's get some space, draw that line. What do we do first? Bring down the 1. Then we multiply and we add. We multiply and we add. We multiply and we add. This was cubic. It's going to become quadratic.
Why did the 12? Wait, no.
Bless you. I don't leave a lot of space for my answer in there. A lot of these are cubic. They're not always going to be cubic. They're not always going to be cubic. So I'm going to try number 4.
Can you do number? Wait, are you gonna do number 5?
I am going to do number 5, but I'm going to try number 4 next. If you're working ahead of me and just checking answers, that's fine, because this can go fast, and I'm doing it pretty slow. So I look at number 4, and I have to find my k value, which is going to be -3. And then I'm putting my coefficients in, but since it skips the x squared, I have to put a placeholder in. Negative x has to be a -1. So I bring down the 2, multiply, add. Multiply, add. Multiply, add. Two x squared minus 6x plus 17 minus 58 over x plus 3. Any questions?
Did you do number? Are you like 100% sure you did that?
What, huh?
Are you 100% sure you did that?
No. What do you think I did wrong? I can check it. What do you think? What part of it was confusing you?
Well, first you start with 1, then -3,
18 plus
7, then plus 6, right?
Yeah.
Bring down
The 1.
and then you multiply 1, it's not -2. So then you put that -2.
No, this is not a negative. This is not a negative.
But over there on the
X minus 2 equals 0.
oh,
So x is positive 2. Or k is positive 2.
That's 6x plus 17.
I don't know what number you're talking about. Oh, yeah, it's plus 17. Well, huh? Oh, there's one thing we haven't covered yet. But there are a couple of these that I want to go over that if you got it, work ahead of me. There's like over here that there's some challenges. Yeah. Who think they know it all. Try the challenges. Then work ahead, dear. Unfortunately, we don't all learn at the same pace, so I encourage you to work ahead. I'm sorry. I was not looking where it was. Here you go. Katie, what do you have different?
I thought that was a 5. I got 51, so I thought you was 9.
Oh, okay. So number 5, I'm putting 2 as my K value. Then I have 1, negative 10, and 2. Bring down the 1, multiply, add, I get negative 14 for my remainder. So this is one that some people are asking about. This one started as quadratic, and if I divide out one of those powers, what's 1 less than quadratic?
It's 4 times 23.
Linear. Why do you have a 4 times 23? Are you ahead of me? Oh, okay. What's 4 times 20? So then, what's 4 times 3? Then add them together. Yes?
So if you put, like, I understand what you mean about online, if you like type it in the microphone, but wouldn't it be negative, and on the outside of the 14 over negative x plus 2?
No, because negative is a negative over a positive, or a positive over a negative. You can't have negative on top and bottom. Are you talking about like, this does not distribute to the top and the bottom? This is only going once to the fraction. So it either goes on top or it goes on the bottom. It does not go to both.
Okay.
Like if I multiply a fraction, 5 over 6, and I multiply that by 3. Do I do the 3 on top and the bottom? No, I put this over 1, and I go straight across. It only affects one of those numbers. Okay? Why did you have 23 for number 6, Daniel? I didn't get a 23 at all.
Wait. How did you? That's not what I got. It's what I got.
That's what I got.
Okay, did you use negative 2?
I know that.
Okay. So for number 6, I did not even have a remainder. My remainder was 0, so I don't have to put the remainder. Okay, if you are to this point, work ahead of me. I can't turn my page over because there's some people checking answers still. There is one more part of this that we need to do. Is anybody still looking at my answers, or can I flip it? Where is this available to you? I'm recording the video right now. I put the link on Canvas so you don't have to Google it. All right, so number 7, negative 3 would be my K value. I'll have a 2, but there's no x squared, so I have a 0, and there's no x, so I have another 0, and then negative 54. Is that 54? Did I do it right? Okay, I'm going to skip the last 3, and if you did them, you can check with me in a moment, but I want to just show you the last part of these notes. This is evaluating a polynomial for a given x value, but we're going to do it a different method. So when you do this on a quiz or a test, it will say use synthetic division to evaluate, or it'll say use the remainder theorem. It'll say something like that.
What's the answer
we can go back and look at it a moment later. That means you are going to do it a specific way.
What's the answer to
We'll go back to that later. I have to finish this first. Okay, so you are going to approach this synthetic division, but what you're really doing, you're going to do synthetic division, but what you're really doing is the same thing that you would do if you were doing f of -4. Which, do you know how to do that? We did it like the first day of this chapter. And you guys just plugged it in your calculator real fast, because I know you know how to do that already, or should. Sometimes people plug it in the calculator wrong. But we're going to do this a different way. We're not going to do it this way, but it's going to be the same answer as doing it this way. We're going to use synthetic division. So in the box is going to be what x equals. Okay, so this would have been like, I'm dividing by x plus 4. That's what I'm dividing by, and then I solve it for 0, and we get x equals -4. So this is -4 that goes in there. They're already telling you what x to put in there. And then we've got 5, -1, 13, and 29. Bring down 5, multiply, -20, add -21. Multiply, that's 84. Add, yes, this one does have bigger numbers, 97. And then multiply, do you know how to multiply 97 times 4 quickly? What's 100 times 4? And then what's 100 times the difference of 97 and 100? 3? Not 100. I mean, sorry. What's I did that wrong place. 3 times 4. Well, I'm doing this without a calculator. 12. Okay. So it looks like 4 is 6. It's 400. So if you do 100 times 4 and you do 3 times 4 and you subtract them, that's the same thing as doing 97 times 4. So what would that be? No, 400 take away 12 is going to be 388. And we add these together.
But it's 97 times 4. But it's 97 times 4.
Yeah, this is what I did right here. I was doing this. 4 times 100 minus 3. Is this 97? So I'm distributing that because it's easier for me to multiply 103 than it is for me to do 4 times 97. So I got 400, take away 12. That's mental math skills because I'm not pulling my calculator out. So now it was a third power. What's our answer going to be?
Why is 417
Oh, it should be negative. I'm wrong, aren't I? I just forgot my negative sign. Sorry. I didn't know what you were meaning. I'm sorry. So we're actually subtracting these. What's 388 take away 30? Because it's take away 29, but like 58. But we're actually taking away 29, not taking away 30. So it should be like 359. Yeah, that's right. Okay. I'm sorry. I was doing quick mental math. Oh my gosh. I just did the thing that everybody does when they miss this one on the... That's not what it's asking us to do. What I asked you before about it being quadratic, ignore me. I got distracted and I forgot what I was actually doing. I am trying to find the value when I plug in x equals -4. The remainder is the value. F of -4 in this equation should equal -359. So I'm going to double check because I just made 2 mistakes in a row. It's not asking you to divide. It's asking to use synthetic division to evaluate, find a value. And normally we would do it this. I'm going to do it this way on my calculator to validate that we did it right. Once I do this, you might understand better. Okay, you see when I plugged in -4, I got -359. But if I were going to do that by hand, if I were in a class and your teacher said you're not allowed to use a calculator, I probably wouldn't do it this way. Because doing it this way, I'm going to have to do -4 cubed, then multiply it by 5, then -4 squared, and subtract that. Like, that is a lot more than just doing synthetic division. So that's why we're learning this. Let's do one more. Let's do number 10. We haven't done any fourth power yet, but let's do number 10. So this is synthetic division. This is called the remainder theorem. So in my little box, what am I going to put? -1. And then -1 is the first coefficient. X cubed is 0. X squared is 1. X to the first is 0. And 4 is the constant. We bring down -1, multiply, add, multiply, add, multiply, add, multiply, add. So when I plug in -1 into this equation, what do I get out? 4. Wasn't that way faster than actually plugging in -1, taking it to the 4th power, taking it squared, like putting all that together? So the assignment is big ideas, so you can check your answers. There will be some of these and some of these, and that's it. Okay? Big ideas, 4.3, day 2. And then if any of you wanted to see answers, like you were asking me, wait, what's the answer for this or that? I can do that for you now.